Hello, my name is Andrew Brooks. This is another presentation of Non-Linear Existentialism entitled Card Playing Robot. The subtitle is A Mechanically Analogous Representation of the Linear, Nonlinear, and Uncertain Aspects of Human Thought. This presentation is used to use an analogy to give an idea of where the other theories of linear, nonlinear, and uncertainty play out for an example that could be more easily understood, such as a card-playing robot. This is going to be the table of contents. Mostly with this one, I'm just going to be pointing out the relevant ideas as you read through, and you can go back. Most of everything is played out in the individual slides, and I won't be reading everything. But again, this is just an analogy, going through what an analogy is, and certain aspects, parameters for the card-playing robot, and how it would play out with the other ideas that were mentioned for nonlinear existentialism. And again, just to emphasize the difference between what's linear, nonlinear, and uncertain or unpredictable, and using special playing cards that the card playing robot would be used, and what would happen through the interaction. So yeah, this is the idea of what an analogy is. You can read it through, and this is going to be the components of a card playing robot (CPR), and the components basically is going to have a robot with a temperature sensitive fingers, which is important. You'll read later on. A desk with an array of special playing cards on top of it with n number of cards. N could be any number of cards. The desk could be incredibly huge or it could be relatively normal size. I'm just going to just determine how big the n is. And later on in the example, I'm going to be using a reasonable n size instead of something that is quite extravagant. But the idea basically can play out. And if you're talking about a system like the human mind, the n number can be in the trillions or even higher. So having a desk of that size with that number of cards on it would kind of make the analogy work against itself because it'd be kind of unrealistic. So with this one, the n number is going to be relatively small. And the other component that's very important is the X lights positioned beside the desk. Each of the lights can either flash green or red, doing so at different frequencies. The other important thing is going to be reactivity. You can read through here, but it goes in the idea of being either reactively too hot to handle or reactively too cold to handle. And this is going to be the idea of, he plays out the idea of emotions and how the cards can be playing against previous systems that have played out through the analogy or ones that just come into play. These are going to be the emotions, but it gives you an idea of also of, as an analogous treatment of the human mind, of how some things cause a strong reaction in causing the amplitude of the neurological reaction to be quite high or to be lower. And these ones are going to be played out against previous experiences that are even set out by the interaction between the card playing robot and the cards. So again, you can read that. And spontaneity, this one's important. The red mark I've put it here. This is going to be towards the idea of spontaneity as it comes to what I was talking about, the central limit theorem. There's going to be a certain percentage of patterns that will spontaneously change. This one is going to be spontaneously too hot to handle or spontaneously too cold to handle, and it's going to be the idea of whereas reactivity plays against a system that has already based on experience. So this one is just going to be a spontaneously occurring event that's going to be unique to the system itself, whereas a system in this way is going to be the card playing robot, which is going to be considered a linear component, playing against the nonlinear components and the uncertain or unpredictable components, which would be the cards. So you have that kind of dichotomy going on. But again, this will be played out later on in the example that's at the end of this presentation. So you can read the algorithm here, and you can see how it starts. The CPR is at a desk with an array of n special playing cards face down in front of it on the surface of the desk, and then how the system starts with a certain amount of green flashing lights and the frequency that they're doing. You can read this through and you can see how it is similar to what was talked about before in the theory itself of non-linear existentialism as it is framed in the nervous system. And just continue on with this one, how how it interacts back and forth. On this one, it's going to be the flashing red lights are going to be basically the idea of setting intervals, time intervals of when the robot's going to be basically turning cards and when it won't be turning cards. and it isn't dependent on what the robot wants to do or is designed to do. It's going to be it has to react to the flashing red light at the desk. So it's going to be an idea that the robot, the usual idea of linearity, is going to be kind of removed from non-linearity, whereas if you've got the system starts with the number of green lights flash at certain rates, that in itself doesn't determine how quickly the system or how quickly the robot turns over cards. It's going to be turned by something that's separate from itself, i.e. going to be non-linear from it. So it's going to be basically controlled by something that can't be basically determined based on the intrinsic movements, intrinsic demands, intrinsic characteristic of the card playing robot. It's going to be something outside of itself, which in this case is going to be the flashing red lights on the desk. And here we're going to be playing out on the reactively or spontaneously too hot to handle, or reactively or spontaneously too cold to handle. You can see the interaction between those about bringing cards up, putting cards down, and also the idea of it as an algorithm with state of rules and regulations of when what would happen. But with this one, the reactivity is something you could predict based on its behavior, can be based on what was happening beforehand. With spontaneity is unique to the cards itself, and that's going to be again reflective to the idea of that was mentioned with amplitude modulation. So the thing is that the amplitude modulation is going to be considered to be a noise or interference that cannot be extrapolated from previous events external to the system or external to the robot. So again, we're just going through this. Please read it through. Just showing the rules and regulations, and it just gives you an idea again of trying to contrast linear with nonlinear, and also the idea of uncertainty. So we're going to also have some more rules here. Please read through this one, and also just going the idea of that you're going to have the beginning initial pattern that initiates a process, then you have the intervening pattern, and then finally a goal pattern. When the intervening or the initial are similar to the goal pattern, the system stops. The CPR no longer starts picking cards because the goal pattern has been attained. And this one again, just going through what I was mentioned previously. Please read this. It just states what has been mentioned before. And the other thing that is interesting is the idea that this type of example can work both for if the initiating pattern is something the robot has CPR seen beforehand, it will react as it has beforehand and come to the goal response relatively quickly, the goal pattern. But if it has not seen this initiating pattern, initiating signal beforehand, this algorithm certainly allows it to achieve an optimized pattern or the goal pattern based on a heuristic with the spontaneity of the cards. Or as mentioned in the previous lectures on non-linear existentialism, we have that brought about due to the interference that's caused or created by the sixth layer of the cerebral cortex. And again, this is just an expression. This is in a different light, so you can see the patterns and characteristics of the system in a way that might be more understandable. This is going to be the learning example, and basically what happens is that we have a spontaneity at 2%, and this has been mentioned in the previous lectures of 0.02, and just having the n number, the number of cards on the table, and the n, the smaller n, just being how many cards are picked per interval to begin with, and that number of cards can certainly change based on the rules with the spontaneity and reactivity, and if the card is too cold or too hot to handle for the CPR, so things can change. Some predictable and some are not predictable. I think it just plays it out. So there's so many different words here, but again, just trying to show how something with just a little bit of variance in it can dramatically change and even with those changes. It just allows things that haven't been considered before to be considered, and allows a playing between something that's considered as a restrictive or a very linear system as a robot, and how just a little bit of spontaneity would cause it to change somewhat, even though in itself it is still a linear system, with just some things that are causing it to change its behavior from being linear to non-linear with change of frequencies, to also on top of it with the spontaneous cards becoming too hot or too cold, that it can come up with a solution that in itself based on previous experiences that you would not expect. So in this one, this is kind of a conclusion, just showing that why the two have been kind of compared to. So linear is flipping of the special playing cards. It's controlled by the CPR and is based on its previous experience, which develops a systematic pattern of picking cards, as well as the RTH-CTH, which is going to be the reactively too hot or too cold to handle. And again, this is going to be based on its previous experiences, and these are mentioned because the behavior of the CPR is going to be in a systematic way determined by how hot or cold the cards are. And then here's when the previous theory has been brought up: non-linearity, frequency modulation, if you're going to be using the other terminology, conversion rate of the different frequency of flashing green lights into a singular pattern, singular frequency, and a set of cards, initial pattern, as well as the subsequent groupings of cards intervening in goal patterns, is set by the time interval as defined by the flashing red lights. And this is again going to be just basically the idea of that the frequency in this cerebral cortex sixth layer, that as is being initiated through the system, causes it to set a certain frequency, and what happens is anything coming into that area, the sixth layer, coming from the higher cortical layers down back through the cerebral cortex, that it's going to be basically limited by that the frequency modulation. So again, the red lights is going to be in this way analogous to the binding frequency that's produced by the sixth layer of the cortex. And then the uncertainty or unpredictability, and also referred to as amplitude modulation, in this context, when and which of the individual special playing cards will become spontaneously too hot or too cold to handle, and certainly not controlled by the CPR. So again, the CPR can be linear, and it can be forced to be non-linear, but it isn't going to be uncertain in its actions. It's going to do what it can, but there's going to be certain things controlled by the cards, and it can only react to them based on its rules and regulations, but the outcome itself would appear to be uncertain or spontaneous because of the interaction between the two, even though the robot in this context, in a normal socially acceptable understanding of a robot, is still linear and can be somewhat non-linear, but it becomes uncertain or appears to be uncertain because it's extra layer which is unknown to others if they're just monitoring the outcome of how quickly or slowly the robot is being able to achieve the goal pattern. So this hopefully is just a quick overview of just an analogy, so you can bring out the many different ideas and thoughts that were brought up in the other presentation. This is kind of like a capstone to the entire YouTube presentations, so that we can understand the idea of central limit theorem, of how the 0.02 that was presented there is again kind of reflected in the cards, and you have a spontaneity of 0.02 to change over. However, this can be modulated quite a bit, especially if you've got a lot more cards. You've got a lot more cards. If you still go the central limit theorem, some cards might have like a 70% chance of changing, or some of them might have like a 0.001 to offset. But there's going to be quite a bit of variance. But when you only have 25 cards, it's better just to say that they're all 0.02. But again, the more cards you have, the more likelihood that the amount of variation given central limit theorem is going to be quite high. I thank you very much for your time in this matter. I hope this clarifies some of the previous points. Again, this is just an analogy just to highlight some other ideas that were mentioned beforehand. There's a lot in this information, even though it's an analogy. It'd be a good idea to look it over a few times, or even just get some cards yourself, set it down, and just play it out for yourself, and you can see how something as complex as ourselves can be brought about just some simple algorithms, but algorithms that are separate from themselves, even though they join together to produce an outcome. I thank you very much for your time. Take care.